Hey guys, welcome back to Limits Edge Machine Works. Today on our video we're going to be going over how to run the lathe a little bit. I wanted to show you some of what we're doing here. We're opening up the central bore of this flywheel to go onto a different engine that it came out of. We're starting from 2.914 inches. Our target ID is 2.990, so we're going to have to remove 0.76. I've already trued this up. As you can see, we've got very little movement of the indicator, well under a thou. That's what we're going to do. That's kind of hard to get less. It's going to really be hard to get less run out than that out here, unsupported on that chuck. And I want to just maybe go over briefly a little bit of how you run a manual lathe. What we've got here is a 200 series quick change tool post. It's just a regular tool holder in it. And I want to check my tool and make sure that I'm coming in here in such a way that I'm not going to be cutting a bevel, that it's going to actually be cutting straight. And it is. It's barely in, but it's still pointed into that corner, so when I run that in and out, it's going to be fine. And as you can see, I'm very near, well, you can't see it, but it's easier for me to gauge these things. I'm pretty near the center line. That's important. We've got two different ways of keeping track of where we're at. You know, we're trying to establish before we start cutting, we need to take that 76 thousandths off to get to our target, and we'll measure it when we get near it. But I'm trying to just barely touch here. Barely touching right there. I can just barely see a line starting to scratch on the surface. Not actually removing any material. And what we've got are zero adjustable hand wheels. So what you want to do, and it's going to be a little tricky to try to do it one-handed, is without moving anything here. So what we could do is, and we've got a DRO as well, so we can zero the DRO. And if you don't have the DRO, this is what you're dealing with here. Try not to move the wheel, but roll yourself a zero around. And as you can see, I did pretty good about not moving anything because we didn't even move a tenth. But that's going to be setting us on that edge there. Now what's interesting about trying to do this two different ways is I can keep track of how much material I've removed here, but I can actually tell the machine where we're at in this coordinate. So not only can you zero, but I can say now, because I measured that hole, that is 2.914, and I'm on diameter, and it rounded down 2/10, but whatever. Now when we start cutting, I can keep track of where we're at on the DRO and on the hand wheel. So I'm going to come in just a little bit, kick this thing into gear and power it up, and then we'll start cutting. I want to keep it extraordinarily slow in the speed for, you know, hopefully some obvious reasons, but this is completely unsupported and kind of honestly a little bit spooky. But that is the nature of manual machining. I hope you've got a good shot of that. I'm going to try to move you in here, get the light right. And I'm not going to worry about the bottom. I'm just going to feel for the bottom. But you don't want to, you know, go hog wild and cut the floor out of anything you're working on either. Okay, so we're in gear. Power feed's off. Everything's good. Oh, helps if I turn it on. I'm going to set my Z0 there because I can hear myself scraping off the floor. So now I've got a Z0 set. And actually you can see that I've come out a little bit and I haven't actually started removing any material or really affecting the surface. So that zero that I tried to scratch for may not have actually been real accurate. There we are. So let's come back to that. zero's good. I refound it there too. I'm gonna leave it. I'm leaving it. So now I'm pretty sure I'm pretty close to being able to keep track of where I'm at. I can just start dialing in some cuts. I don't want to take a bunch, so I'm thinking about 20 thousandths here maybe. No, mainly I don't want to take a bunch because this is completely unsupported and rotating right at my body, and although it's only turning 70 RPM currently, there's still, you know, no need to get hit in the chest with a 8 pound flywheel turning 70 RPM. Might knock the wind out of you. That's my Z0. I'll back out, dust it off, put a little lube down. I'll switch the camera angle up since you've seen it from that side. Let's try to see what you're doing when you're operating here. As you can see my first cut. Right there. Should be around 237 now. And one way that you can see, we'll just shut it off. And that's one real good way to see, okay, did I actually, how close am I to really knowing where I'm at? So you can stop after your first little light cut, wipe things off, get your calipers back out, and if you're off, you can make an adjustment and just tell that DRO, okay, well I missed it. But I'm not moving the hand wheel or anything. I said 2.937 is what I've got on the DRO, and I've got over 2.936, so I'm within a few tenths of it. But from the operator's perspective, that's what you're dealing with. And this lathe, although it says Shop Fox on it and it's beige, it's the exact same thing that Grizzly sells as their Grizzly, as Inco sells. There's a few people that deal in them. I do have the older version that had the removable gap bed, although I've never had the gap out. And we're running a chuck that doesn't come with the machine today. This is a 8-inch chuck, 3-jaw, regular self-centering chuck. But as you can see, we're able to locate off of, I should have showed you that already. The chuck is actually just squeezing inside of the recess for the clutch bore. It is a finished surface, so it's concentric. You know, it's gonna, you let you chuck up on it and get it pretty close, and I just tapped it in a little bit and we were there. But enough rambling. Let's hog some more material out of here. Not hogging anything, but let's cut some out. Oh yeah. Put it back in gear. So we'll just take 20 more out. And you could use the auto feed. I don't really use it all that much. And the tripod's in the way right now a little bit. I'm trying to operate everything at once. We're just taking a real light cut. I'm not trying to force anything. I'm just watching the chips flow out of there. I'm keeping steady pressure on the tip of that tool. Leaves a real nice finish. I'm keeping track of the Z0, both by watching the edge of the cut go towards the bottom of the shoulder we're cutting, and by watching the DRO. 9, 8, 7, 6, 5, 4, 3, 2, 1. 0. That's it, that's the floor. Now we can back out. To brush the chips off. I'll try to move again so you guys can get another shot of it. I know this stuff may be boring, but a lot of people ask me, I hear that question a lot. People say, how do you run a manual machine? I even work in a shop where all we have, well, we have one manual machine in my shop. 27, I think, CNC machines, new one going in Monday morning, tomorrow morning. But one manual machine. It's funny, it's the most interesting thing in the world there to the operators and everyone. How do you run the manual machine? So let's try to give a view of the controls and everything at once. And I'll explain it a little bit. And that hopefully shows everything a little bit. You can still see the work rotating. We're not going to be able to see the cut as well happening right now, but I've already shown you the cut, so just cut back and see that if you want to see the cut again. And we've got a few controls here that I'll talk about. Go ahead and shut the machine off so it quiets down. We'll talk about the controls for a second. We've got our compound here. It's typically on a manual lathe going to be set near 30 degrees for single point thread cutting. But the compound's adjustable from 0 to 90 or a little more. Gives you different approaches with this, but it's a little weaker. So I like to keep mine set at normal, but also kind of jammed against the end of the screw. Which maybe not the best thing to admit on camera, but it gives it a little more rigidity. I don't ever move it, literally never, so it doesn't hurt my feelings. Then you've got your compound that goes across this way, which is going to cut across the face of the work. On this machine, on most machines near this size or bigger, you can have power both directions. This one does have power both directions. It's on a double cut V-way with a tapered adjustable gib. It's got 3 oilers in the middle, 2 for the sides, 1 for the screw. The carriage does have lock screws on it, so you could lock the carriage if you wanted to. This is your cross slide, this is your compound slide, this is the carriage. This thread counter keeps track of where you're at if you're cutting manual threads. We don't need to talk about that much today, but this is your forwards and reverse. It's got an interlock, so right now I can't power it on. You just pull that over towards you, and then you have forwards and backwards. This is going to grab the lead screw if you're cutting threads, and this lathe transmits power through 2 things, this screw and this shaft. If you are going to be using the power feed, that's how you're going to engage it. This lever here, again with an interlock. This way for this direction, that way for that direction. And it can power the cross slide back and forth, or that can power the carriage longitudinally. For carriage movement, you've got a fast wheel here. And all of these have dials on them so you can tell how far you've moved the screw, or whatever you're moving, you can tell off of the dial how far you've moved it. And they all have, except for the carriage, they all have adjustable zeros. I've added the DRO. The DRO is nice. It does everything that these do, except it does it a lot more accurately. When you're trying to keep track of where you're at on a manual lathe or a manual mill, you have to compensate for backlash. So if I set a 0, which I did on this hand wheel, and I wanted to go past it and then come forwards again to 0, I would not be on that 0 because I've got that backlash in the screw that I'm not thinking about. So my 0 only matters if I come back at it from the direction that I set it. So that would be 0, but from the other direction it would be off a little bit, whatever the screw is worn into the nut. And that's, again, that's something that's adjustable. The screws and the nuts are typically, they got a bronze nut in there that's split and has a pinch bolt in it. Things like that that help you take the lash out of your movements. That's actually the scale I mounted for that cross slide DRO. That's longitudinal Z-axis scale is tucked up underneath the back side of the bed there. It's actually out of the way. Everything's pretty coolant proof as well. I've got my, and this machine actually has coolant flow, which the Grizzly does not. The coolant tank and pump are mounted up under the chip tray. I've got it all kind of octopus fed off of here. You've got your stale feed, your coolant, and power for the light and everything. But, we're rambling on about how the lathe works. I really wanted to cover it though, because a lot of people, it's funny, like, I've got probably 60 guys at work, and the operation of this is like a foreign concept, and it is, because it's kind of a blast from the past. You run 1 job, 2 jobs. We don't run production on these at all anymore. It's just for something like this where you've got, a guy got a flywheel, got 2 or 3 different engines. He's trying to build a hot rod Honda project from the 70s. It's a really neat car. I'll try to show you the car later. But you know, he's got this really great flywheel with a good surface on it. He's tried to put it in the engine and it won't fit because he's 76 thou off on that bore. Well, you know, you're not going to see that every time, or you may not know that they made a change, and it's not that big a deal. But that's where the beauty of an engine lathe like this style of lathe comes in. And if it were just a little bit bigger of a flywheel that we couldn't chuck up, we could remove that gap. And I think you can swing. The swing over the gap is 17.5 inches, so you can swing a pretty good circular disc right here close to the chuck. And that's where the gap is. You can actually see the end of it right there, where the interior trapezoidal rail ends. That section is removable. The lathe does have induction hardened V-ways, and the flats are hardened. But let's get back to cutting. So make sure I'm at the right 0. Yep. Okay. And we're back in gear. That's where we were, is right here. So we can come back. I know that's where we were. I was just keeping track of it. We had 40 thou taken out of the 76 we needed. Here's going to be another 20 out. That would give us a total of 60 thou that we've removed. Now, I like to feed everything by hand because I can actually feel and hear that if I get to the bottom of that, I can stop myself. On this machine in particular, you don't have any adjustable stops or clutches that can kick the power feed out. So if you do power feed into the bottom of whatever you're cutting, let's say I fed that tool with power feed directly into the bottom of that flywheel, it would just break something, whatever it gave up first, or it would break multiple things. You know, you'd shatter your insert first, and then the insert holder, and then the tool post, and the compound would hit. And you'd have to actually come over here and shut it down before it started shearing gears and shafts inside and just stopped transmitting power. Now, that was actually 3 thou into the floor there, but that's alright, I'm still watching it. So right now we're at 29772 off the DRO. I want to get us a little closer before we take another measurement. There's no reason to get too nervous about it. I'll put us within 5 thou there of our nominal target. And we're actually going to go a little bigger than what we talked about anyways, because I don't want it to be a press-on fit. And I'm going a little slow. Let me show you there. See, we took the lighter cut, and I can get right through that. Go to the floor, come back out. All right, now I want to measure it, just so we don't cut too deep. It's really easy to remove material, and really hard to put it back on. So all that stuff that the woodworkers will tell you about measure twice, cut once, blah, 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 sneak up on your cuts, all that stuff, yeah, do that. That's part of doing one-off jobs. So I am, let's see here. I'm getting 2980 actually, is all I'm getting. So we may have wore a little bit off the insert, or you know, whatever, it doesn't matter. We're just keeping track of it 2 different ways here. The calipers are accurate. Now what I want to go ahead and do is go to the size that I want. I'm going to set that to 2991. Now we'll go 2990 and a half. Cut into that a little bit so I know I've hit the floor hard. Which may not make sense to you guys, but it doesn't hurt to put a little bit of a shoulder or a little relief in the bottom of that. Instead of a sharp radius, you can use the geometry of the tool to go ahead and make your own little radius that's better. So don't cut it just sharp out of there, you know what I mean? If it's got a little ditch in the backside, it never hurt nobody. That's where the stress will go and dissipate instead of a sharp edge, where it'll go and concentrate. Okay. Let's see what we've got here. It should be right on the money. Yep, and it is. We've got just under the 1 mark there, so 2991. Now the last step of the project that we were doing here is to go ahead and cut a chamfer on it. And what I'm going to do is cut that on the back side. So I'll get this back around here. And I'm just going to use the natural back side of that tool's angle that we've already got. And I don't have to move the tool or do anything different. There we go. You will notice though that since we're moving to the other side, if I want this tool to cut, I can't spin the work the same way. So I've got to go in reverse. That way. And that'll let us come in here and cut a little chamfer on there. Whew. I think I actually just touched that tool holder body to that flywheel. And then you can take a little emery cloth and shine that up. Take any burrs that you've left on it, give it a good finish. Anyway, hopefully what I've been rambling on about here makes some sense to everybody. And you can tell a little bit more about how manual lathe operations would work. And this flywheel can go back on the engine that the guy wants to use it on now. And he doesn't have to go hunting through the junkyards for another one. Well, thanks for tuning in, everybody. If you haven't already done so, please subscribe to the channel. Give me some likes, share, comments, ideas for new things. I'm actually thinking about getting rid of this lathe. So let me tell you, I want to know what you think about that. If I get rid of the lathe, I can get a 4-axis, set up little CNC mill and do a lot of work on there. And I almost never use the lathe. A lot of the jobs I run on the lathe, we could run on a 4-axis CNC mill. It'd just take a little longer and it'd be different. But give me some feedback on that if you don't mind. Thanks again, you guys. Hope you're taking care of things in your shop. Make some chips, put some paint on something, throw some sparks, do your thing. Really appreciate y'all.